Hello class, this is a continuation of the example videos for angles of elevation and depression. Let's get straight into it. So Bob is standing 75 meters from the foot of a 30.93 meter tall structure. Okay, this is a little bit wordy. Bob is standing 75 meters from the foot of a, don't worry about that, from a tall structure. Okay, so here's Bob, and here's the foot of whatever structure it might be. So let's put B for Bob and S for structure. It's the foot of the structure, and we know he is 75 meters away from it. That is 75 meters. So the structure, we don't know what it's going to look like, so let's just draw a pole or a stick to represent that. I'm pretty sure you've noticed that's how I go about drawing these structures. And here's the top of that structure. So Bob is standing 75 meters. Bob is standing 75 meters from the foot of a 30.93 tall. Okay, so this must be 30.93 meters. Okay. And here we have our angle. Oh, sorry, our triangle. And a 90-degree angle. Calculate the angle of elevation of the top of the structure from where Bob is standing. So from where Bob is standing, the angle of elevation is what we want. So we really want this angle here. So let's label that as theta. Now let's go about using trigonometry to solve this question. So from this angle, from the reference angle, we have a opposite and an adjacent. So this here we have opposite and adjacent is using tan. So tan theta is equal to opposite 30.93 over 75 inverse trigonometry. Theta equals tan inverse 30.93. Inputting this into our calculator, we get tan 30.93 over 75 angles. Using this button, we get 22 degrees 25 minutes, because we round up from 40 seconds to the nearest minutes. There we go. Let's get to the next one. I invite you now to pause the video and give this one a go. And I'm going to be solving it in 3, 2, 1, let's go. So Joe notices Greg standing on top of a watchtower. So Greg is standing on top of a watchtower. Let's draw Greg. Put here. Here's our watchtower, and Greg is standing on top. Joe notices him, okay, standing on top of the watchtower. We don't know where he's standing. Okay. It says it here. Calculate the angle of depression from Greg to Joe. So Joe is underneath Greg somewhere here. So Joe is somewhere over here. If the tower is 85 meters tall, so this is an 85 meter tall tower, and Joe is 12 meters, Joe is standing 12 meters away from the tower. this is presuming that Joe is standing on ground level. So let's make that assumption, and let's continue from there. Here we go. Here we go. So here is our triangle. Now, Joe is 12 meters away from the tower. So this is 12. Let's reread this just to be sure. Joe notices Greg. So Joe is here. Notices Greg standing on top of a watchtower. Here's our tower. Calculate the angle of depression. Okay, this is a bit odd. From Greg. Okay, so this means from Greg, we're going to be drawing a horizontal line of sight. Because that it says calculate the angle of depression from Greg. So Greg gets a line of sight there. To Joe. So from Greg is looking straight until he looks down and notices Joe back. So this here is the angle we are calculating. We can go about this in two different ways. Okay. We can either extend this triangle out like this, like I've done in my previous video, and make a mirror image of this, where this is 85 and this one here is 12. Or if you understand properties of parallel lines, this is parallel to this, we have adjacent angles. So this angle is equal to this angle. Or we can take this as 90 degrees and just calculate this one here. And from this angle, which we can calculate, we can figure out theta. I'm just going to go ahead and pick this one here because it takes the most steps. Because why not? You can go about this using any method that you like, as the ones I've mentioned. And you can check with the final answer that I'm about to show you. Here we go. So let's calculate this angle here, x. Let's say we have sine x. Oh, is it actually sine? I made a mistake here. We have an opposite and an adjacent from this angle. So that must mean we use tan. So tan of x is equal to opposite over adjacent. So we can use inverse sine to calculate this. Tan inverse. This will give us shift tan 12 over 85, 8 degrees and 2 seconds. 8 degrees 2 minutes. 8 degrees 2 minutes. But be careful now, because this isn't the angle of depression. It's this one here. We want theta. Since we know theta plus this angle is 8 degrees 2 minutes, it'll equal 90 degrees. We can calculate theta by subtracting 8 degrees 2 minutes. So 90 minus 8 degrees and 2 minutes. You can do this by simply inputting it. 90 minus 8 degrees 2 minutes. We have 81 degrees 58 minutes, and that is to the nearest minute. That concludes the last few examples, and I hope this gave you plenty of insight into how to work with angles of elevation and depression. Best of luck.